Yaskawa.
This video shows how to set the programming user units for a linear load and a rotary load. Here's a quick preview of everything I'll show in this video. Units for motion control function blocks, such as the distance, velocity, XLD cell input, are defined in the hardware configuration. In hardware configuration, under each Mechatrolink axis, the configuration tab is used to input the mechanical system details that define the units. An online save and reboot is required for the changes to take effect. You can go to Help, Contents, Mechatrolink Configuration, Setting User Units to find documentation and a good example. Now I'll go through a different example in detail. I have an MP2300 SIEC controller with two different Mechatrolink servo axes. Sigma 5 SGDV rotary axis 1 is connected to a 10mm ball screw actuator through a 5-to-1 gearbox, and I would like to program this axis in units of millimeters. The second axis, SGDV rotary axis 2, drives a rotary table through a 3-to-1 timing belt, and I want to program this axis in units of degrees. I'm in the hardware configuration. You can see that I'm online with the controller, and I've reset the controller to factory default, including the controller, amplifiers, and motors. First, I'll configure the units of the linear axis, rotary axis 1. Go to the configuration tab, and you set the units here in the pull-down menu. I'll choose millimeters. Unit selection does not affect the controller operation, but it is available for reference and display within the software. Now under feed constant, the equation indicates that we need to enter the units moved per load shaft revolution. And this screw was 10 millimeters per revolution, so enter 10. Any gear or timing belt reduction is combined and entered as a ratio of input rotations to output rotations. I said this axis has a 5-to-1 gearbox, so that means that 5 input rotations produce 1 output rotation of the load shaft. Now, I skipped over the top field here, machine cycle, because machine cycle is only used when the load type is set to rotary. The load type is down here, parameter 1807. The load moves linearly for a limited distance, and so the machine cycle does not apply when you have a linear axis. SGDV rotary axis number 2 is the rotary table, and I'll go to the configuration tab. The units here are degrees, but you see that degrees are not an option. First, I'll have to set the load type to rotary, and now I can choose degrees for the units. Feed constant for the rotary table is 360 degrees per rotation, and the timing belt reduction was 3-to-1, so 3 input rotations for every 1 rotation out. This axis is a rotary load, and so we do have to set the machine cycle. Rotary load means that the load is able to move infinitely in one direction, eventually arriving at the original position after 1 machine cycle. So at 360 degrees, the table is back to position 0. You might have noticed the red text, which if you scroll down, it reminds us that we need to save and cycle power for the changes to take effect. But also you see a note below which says that the combination of absolute encoder and rotary load type requires setting the encoder multi-turn limit, PN205. And you can look down here, PN205 multi-turn limit setting. We should set that to the gear ratio input, which we have set as 3, minus 1. So whatever we have in this area, minus 1. We'll put in 3 minus 1 is 2. For more details on the absolute encoder and the multi-turn limit, you can look at the Sigma 5 Servo Pack manual and refer to chapter 4.7.6, multi-turn limit setting. To complete the configuration, be sure that you're online and then save. This saves the updated configuration data to the project and sends it to the controller and amplifiers. Every online save requires reboot for changes to take effect. Okay. Under the online menu, reboot controller. Reboot controller does the equivalent of cycling power to the controller and all of the connected Sigma 5 axes. Reboot is complete, and so I can connect again. Online now, I can see that that axis number 2 under the alarm tab has an alarm for multi-turn limit disagreement, alarm ACC0. To clear this alarm, we need to send that setting here, 2 for the multi-turn limit, into the encoder. So to do that, I'll go to the web page, log in so that I can get to machine operations. Then under the Drive PN tab, choose the axis that has the alarm ACC0 and perform the multi-turn reset. Click OK. And now back in the hardware configuration, I'll reboot a second time, reboot controller. Yes. I'll connect again, and I can see that there are no alarms. And the axes are set according to their mechanical properties. I could now go ahead to do a test move with these units. And when that's done, I can close the hardware configuration and begin programming with the units that I've set. Thanks for watching this video, and remember yaskawa.com/IEC for application notes, videos, firmware updates, and more.